Mr. Monahan here for lesson 1.3, Prob and Stats. I can explain what a permutation is and how to compute by hand and with a calculator. So we're going to look to expand on what we know about factorials and fundamental counting principle today. So we're still figuring out how many different ways things can happen, events can have as far as outcomes. I'm just giving you another strategy again today. So that's what we're going to look at doing, and we'll get started here. First thing I want you to do is answer this question. All right, there are 30 people in our class. How many ways can I choose 3 students to leave first, second, and third? I want you to pause the video and answer this question here. Based on what we've talked about already, how are you going to answer this problem? Okay, go ahead and pause right now. All right, so after you've looked at working on that one, now let's go over the answer. If there's 30 people in our class, I'm gonna take that 30 and use it. This part's gonna be important. I want to choose 3 students, which means I have 3 choices. So I want to set it up in some way like this: something times something times something. Okay. Hopefully you got 30 times 29 times 28. Again, the 30 is because that's how many people we started with. But whoever went first can't go second, so there's only 29 people for the second one and only 28 for the third. Now that's something that we've been working on. We talked about that last week. So why is that different, or why are we talking about it today? Well, there's another way to do this same problem. This is an example of something called a permutation. Okay? A permutation is a specific order or arrangement of a set of objects or items. So the most important part of that definition is it's putting something in a specific order. So take a second and write that down. When we're talking about permutations, we're saying something has to happen in a specific order. Kind of like we had those questions about doing chores. How many different ways can you do chores in a certain order? Okay? An important question to ask yourself when it comes to this, when you read a word problem, I want you to ask yourself this question. So write this down. Does order matter? That's going to be a question you need to ask yourself this chapter. Okay? If it does matter, then you're dealing with permutations. Okay? We can use another strategy to do the problems we've been working on so far this year. We can use permutations if the answer to the question, does order matter, is yes. Okay? So let me tell you a little bit more about them. But when we're looking at these, we're going to look at, we can do this because the order is what we're looking at mattering. So here's the symbol for permutations, NPR. So you can read it just like I read it, NPR. Another way to think about it is NPICR. We're picking a certain order of the R items. Or lastly, N permutations, I'm just going to abbreviate that, of size R. Okay, those are all good ways to think about it, but here's a good one too. There are N objects, and you want to put R of them in order. So of the N that I have, I'm putting R of them in order. Okay, there's a formula for this. Let me copy it down for you. It would be N factorial, remember that's an exclamation point, over, let's do parentheses here, N minus R factorial. All right, and you don't have to have that formula memorized. I'm going to show you how we can use it here in just a second. But for now, let's just look at it this way. N factorial over N minus R factorial. Let me prove to you that that's the same thing that we just did up top. Okay, so another way that we could have done this problem, 30P3, because there's 30 people in our class and we're choosing 3 students to leave in a specific order. Remember, if we're asking, does order matter, the answer to this question is yes. Leaving first is different than leaving second. Okay? So 30 picking 3, let's use the formula for that then. 30 picking 3, that would be 30 up top. Remember, the one on the left is N, over 30 minus 3 factorial. Well, that's 30 factorial over 27 factorial. Let's think about what those are. That's 30 times 29 times 28 times 27 all the way down to 1. All right, on the bottom it's 27 times 26, blah, 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 all the way down to 1. Okay, we'll take a look at these. From 27 all the way down to 1, that's the same as what this piece is. So we have the same thing on the top of a fraction as we do the bottom, so those can cancel. What we're left with is 30 times 29 times 28 and nothing on the bottom, and that's exactly what we set up here. 30 times 29 times 28. So there's two ways to do this one. Whichever one makes more sense to you is great, but ask yourself the key question, does order matter? That's a big one. Okay, so let's move on. We'll do a couple of these by hand just so you can see it a few more times, but we're not going to do this much more. After this one, I'm going to show you where it is on the calculator, and we'll just start doing that. So 4 factorial, or 4p2, that's going to be equal to 4 factorial over 4 minus 2 factorial. So that's 4 factorial over 2 factorial. Well, that's 4 times 3 times 2 times 1 over 2 times 1. But these two things are the same, so they can cancel, which means I'm left with 12, 4 times 3. Okay, let's do one more of them. 5p3, let's do that one. So that's 5 factorial on the top, 5 minus 3 factorial on the bottom. We're left with 5 factorial over 2 factorial. So we have 5 times 4 times 3 times 2 times 1. On the bottom, we have 2 times 1. These two things are the same, so there's always going to be some things that will cancel. 5 times 4 times 3 is 60. That's great, and that's fine. I'm going to show you how to do it on the calculator, and from now on, we're going to do that. So depending on what calculator you have, it could be different. I'm going to show you on the graphing calculator. No matter what, whatever calculator you used previously to find your factorial button, the exclamation point, your permutation button should be really, really close to that. So we're going to try to find the permutation button to do 23 pick 6. Now, these are normally going to be really big numbers, so don't be worried that maybe you type something in wrong if you get a large number. Start by typing in your 23, and again, we're finding this math button right here. After we find the math button, we want this probability tab, and again, it'll be different on different calculators. Here's where we found our exclamation point before. See where it says NPR, that's what we want this time. So I want the second option there. So I have 23 permutations of size, this time it's 6, and we're going to get a big answer, and that's okay. This time it looks like we have 72,681,840 would be our answer. Okay, let's do the 12p10 while I have my calculator up. 12 picking 10. That's going to be even bigger. So we have 12. Here's the math button. Here's the probability tab. And the permutation is the second one down. 12 permutations of size 10. Another big number. Looks like we have 239,500,800 for our answer. Permutations are going to give you big answers. Okay. Let me know as soon as you can if you can't figure out where your permutation button is, and I will help you figure that out. Okay? So let's do this part of the question too. Explain everything you can about the answer. Okay? So for this one, what it's saying is I have 23 objects. I want to know how many ways can I put 6 of them in order. That's what this means. For the second one, I have 12 objects. How many ways can I put 10 of them in order? Okay, there's going to be a lot of ways you can do that as soon as you start getting some bigger numbers in there. Okay, moving on. The difference between figuring out 5 factorial and 5p2. Well, if you're talking about your calculator, they're just two different buttons. 5 factorial is just that 5 times 4 times 3 times 2 times 1. So 5 factorial is this, which is 120. 5 picking 2 is 5 factorial over 5 minus 2 factorial. So in this one, you're going to have some division because we have 5 factorial over 3 factorial. And when you start dividing by factorials, you're going to get some things that will cancel. So that's what we have in this situation. So this is only 5 times 4, which is 20. Okay, so they're different, but again, I wouldn't spend a lot of time doing them by hand since we have technology that will do it. Okay, so word problem examples. We'll go through some here. It says, ask yourself if it's a factorial or a permutation. How do we know if it's a permutation? We're talking about, does order matter? Okay, factorial, we'd be listing everything all the way down to 1. Permutation, just NPR. We want to know if order matters. All right, let's try some. Find the number of ways 4 members from a family of 5 can line up for a photo shoot. So family of 5, that's my N. 4 members, that's R. So I have R right here. I have N right here. I want to know how many ways they can line up for a photo shoot. Order matters in this situation because being all the way to the left is different than being all the way to the right. So we have 5 as our N. We're picking 4 of them. 5p4. Okay. You can do the formula for it. Let's not do that. Let's just have your calculator ready so we can get through these a little bit faster. So we have 5. We're going over to math, permutations, 5 permutations of size 4, which is 120 different ways you can do that. Okay. Moving on. And we'll just kind of get through these here quickly. In how many ways can the letters R, S, T, U, that's 4 letters, be arranged to form codes of 2 letters? So that's R. So here's N, here's R. So we're doing 4 picking 2, and we had that answer up here somewhere. 4 picking 2 was 12. We already said that. But you can punch that in and make sure that you get 12. Okay. There are 12 people in a jury. The lawyers have 15 people to choose from. How many different ways can I order the chosen jurors? So there's the bigger number first, 15. We're picking 12 of them. We'll go to the calculator for it. 15, picking 12. We have math, probability, second option, 12. Get ready for a big number. Okay, so this one is written in standard notation. Scientific notation. Sorry, mixing up my classes here. So scientific notation is just a way of writing really, really big numbers. So here's how we'll write this one. Just write 2.17. Okay. Let's even take one more number. 2.179. Okay. Times 10 to the 11th power. The 11 came from right here. It's whatever's after the E. So just take the first few numbers of those if that happens to you, and we'll punch it in that way. Okay, there's 15 people. I'm choosing 12 of them in a certain order. That's a really, really big number. Okay. Joe, Amy, Brad, Sarah, Nick, and Kathy. Let's count those names up. 1, 2, 3. Looks like there's 6 people here. Are in the Writers Club. We want to know how many ways are there to pick a president, vice president, and secretary. Those are 3 different jobs, which means the order matters for those. There's 3 different jobs for 6 different people, but being president is different than vice president, which is different than secretary. So this is still a permutation problem, 6p3, and we're going to go to the calculator and grab that answer, 6 permutations of size 3, and we get 120. So there's 120 different ways that club can pick a president, vice president, and secretary. Okay. This one says there are 8 members of a track team in a race. How many ways can they finish 1 through 8? So notice that this is all of them. This is all the racers. So you could do it as 8p8, but look what you're going to get. You're going to get 8 factorial over 8 minus 8 factorial, which is 8 factorial over 0 factorial. We said that that equals 1 the other day. So it's kind of like saying 8 factorial over 1, which is just 8 factorial. So you can do the 8p8. Oh, I'm sorry, I'm in the way. I didn't show you this. Okay, so what I'm saying is you can do 8p8, but that's really the same as 8p8 is equal to 8 factorial. So if you're doing 8 all the way down to 1, you can just go right to using factorial. You don't need to do the p formula every time. If you're picking everybody, then we're just going to have you do factorial. It's the same thing. Okay, so 8 factorial is 40,320. So if everybody is getting placed, just do factorial. Okay, we'll see. I'm sure we'll see a couple more of those as we go. 50 people each bought a raffle ticket. First prize is 500 and second prize is 200. So there we have order mattering again. And how many ways can the winners be chosen? So here's my bigger number. There's 50 people that I'm going to pick 2 winners from, first prize and second prize, where order matters. So we're doing 50p2. Make sure you can get some of these in your calculator, but just to speed it up, I'm not going to show it every time. 50 picking 2, there's 2,450 ways to pick a first prize winner and a second prize winner. Okay? How many ways can the 10 digits 0 to 9 be written in order? So that's 10 digits, and we're writing all 10 of them are going to be given a place. So you could do 10 picking 10, but I would say just do 10 factorial. So when everything's getting its own spot, we're using all of the objects, we're using all 10 objects, that's called factorial. So now that's, if you punch that in, we get 3,628,800. Okay. Same with these ones. These are going to be either permutations or factorials. It depends on if we're using all the letters or not. So in pencil, it says, so how many permutations are there of the letters in the following words? So they're saying all letters. So these are both going to be factorial problems. We're going to use all the letters in the word pencil. Pencil has 6 letters. They're all going to be rearranged, so that's 6 factorial. 6 factorial, when you punch it in, gives you 720. So there's 720 ways to rearrange those letters. Okay? Florida, that has 7 letters, so this is just 7 factorial. If you do 7 factorial in your calculator, that's 5,040. Okay? Moving on. Oh, that's going to be it for today. So when you look at permutations, the biggest question, again, is does order matter? That's what you're asking for. That's going to become a big deal as we move on to the next couple things, because sometimes the answer to that is no, and then we have to do something else. But that'll be in a future video. So today's assignment will be pages 11 and 12, and then you have your online homework checks to make sure that you're getting the questions right. All right, thanks for watching. Go ahead and give it a shot.